Good morning, everybody, or good afternoon or evening, depending on where you are. Welcome to the third and final session of Instruments of Change, which marks the official launch of the Environmental Modeling Lab at the Stuart Weitzman School of Design. I'm Karen McCloskey, Associate Professor of Landscape Architecture, and on behalf of my MLab colleagues, Sean Burkholder, Robert Piotrusco, and Keith VanDerSys, we want to thank you all for being here today. And if you missed session 1 and 2 on Tuesday and Thursday, all of these will be posted on the MLab website by the end of the month. I also want to thank again our Dean Fritz Steiner, our Chair Richard Weller, and the Wilkes Family Director Billy Fleming for their support of this event. Today's session is going to be moderated by Keith VanDerSys, who you've already met, moderated the first day, Senior Lecturer in the Department of Landscape Architecture and co-founder of the MLab, and Anya Domlesky, who is an urban designer and landscape architect. She is Director of Research at SWA Group, where she runs the XL Lab, the firm's innovation lab, undertaking practice-based research. And the lab explores near future conditions in the built environment, performs analysis of design performance, experiments with new technologies to create tools for the field, and does topical investigations that address emerging complexities and unprecedented design challenges. Her research has been exhibited in the Shenzhen and Venice Biennales and is published in books such as Third Coast Atlas and Studio Ecologies. Her design work focuses primarily on issues around urbanization, coasts, and water, which is something that I think you'll hear a lot about today. And Domlesky has previously worked at the New York City Department of City Planning, Waterfront and Open Space Division, and Hood Design, and also taught at Harvard University's Graduate School of Design and Boston Architectural College. So welcome, and Anya, I'm going to hand this over to you.
Thanks, Karen. So I'd like to welcome you to the third and final session of the symposium. This session, Experimental Landscapes, Monitoring Change, considers place-based experiments that engage landscape dynamics directly on the ground, in contrast to the previous session's emphasis on perhaps a more distanced techniques of mapping and modeling. I'd like to thank the organizers for the invitation to be a part of this symposium. And as Karen said, my name is Anya Domlesky, and I'm doing practice-based research. I would say I was probably invited because I think that we as landscape architects should be making our own tools, or at least modifying others. And I also work in coastal environments, like Karen mentioned, which happens to be the context for most of the work that will be presented today. Let's see. So to introduce, sorry. Okay. Can you see my screen okay?
Yes.
Okay. So to introduce today's presenters, we have 4 presenters who will speak for 20 minutes each, back to back. And there'll be about 40 minutes for questions and discussion at the end. So please feel free to put questions in the chat as you have them. You don't have to wait for the end of all the presentations. You can just use the Q&A function and type your question there. So in alphabetical order, which also seems to be coastal order, we have first Sean Burkholder, who's Assistant Professor of Landscape Architecture at UPenn, where he's also the co-founder of the Environmental Modeling Lab, or MLab. He's also co-founder of the Research and Design Practice Proof Projects and a member of the Dredge Research Collaborative. Burkholder's work bridges environmental modeling and monitoring and modeling, and includes working with ecologists and engineers on large coastal infrastructure projects, one of which is Healthy Port Futures, a part of which I believe he'll be talking about today. Monica Chasten is a coastal engineer with the U.S. Army Corps of Engineers. She has been instrumental in innovative projects that use dredged material to restore marsh and support resilient shorelines, from development to construction to monitoring. She serves as the lead for the Philadelphia District's Engineering with Nature Proving Ground, which is linked with the Corps' Engineering Research and Development Center, or ERDIC. And she is also co-lead for the 7 Mile Island Innovation Laboratory, which I believe we'll be hearing about today as well. Iryna Dronova is associate professor in the departments of both landscape architecture and environmental planning and environmental science, policy, and management at UC Berkeley. Her research combines landscape ecology with remote sensing and geographic information science to investigate dynamics of human-dominated landscapes. She is particularly interested in how the increasing accessibility, spatial resolution, and temporal frequency of remote sensing products can facilitate landscape planning and decision-making and strategically complement ground-based data collection and monitoring. So I believe we'll hear about this complement today with case studies on wetlands and urban heat. Brett Milligan is Associate Professor of Landscape Architecture and Environmental Design at UC Davis. He is also founding member of the Dredge Research Collaborative, which explores sedimentary processes and landscapes through public events and design. He is also director of Metamorphic Landscapes, a research lab working on adaptation to environmental change through immersive fieldwork, ethnography, and applied design research. And I believe we'll hear about 3 design experiments in the San Francisco Bay that use this integration of fieldwork and design. So with that, I'd like to hand it over to the first speaker, Sean Burkholder.
Thank you very much, Anya. That look good for everyone?
Yep.
Great. Okay. Wonderful. Thank you, everybody. Welcome this morning. Today, I'd like to discuss the role of experimentation in the practice of landscape research and design through a pair of case study projects associated with our Healthy Port Futures initiative. But before we get there, I'd like to quickly go over, or at least lay out some kind of framework for which I see the various roles of experimentation and landscape architecture, or landscape, we'll say research, design, and making, as a way of providing some context to the projects I'll show shortly. So to begin, I'd like to briefly describe how, at least I define the term experiment and how I'll be using it during this talk. An experiment is designed to test a hypothesis or a guess about the nature of a relationship between 2 or more variables through observation. Its component parts are thus this hypothesis, a collection of variables, some dependent, some independent, various factors that need to be considered or blocked as they impact the relationship between these variables of interest, and the methods for observation, recording, and interpreting the feedback that is generated. Moving forward, we'll see how our kind of ideas of landscape can plug into this definition, and you'll see that landscape architecture is certainly not without its experimental legacy. That said, there are clear reasons why experiments are not typically a fundamental part of the built landscape. Primarily among these is the assumed and yet unknown failure associated with any good experiment. Building a project that will knowingly fail, yet with uncertainty to what degree this failure will occur, is obviously a difficult way to establish credibility and support as a designer. However, it is exactly the way we could be working if we want to learn about the world we live in through what we do. So this is something that is easy to accomplish abstractly by way of models in an academic environment, but it's very difficult in the real world of constructed projects. Because of this, most projects could be understood as a kind of a type of hypothesis or guess about what the future will be. These hypotheses tend to be large, general, at times convoluted, and are quite often packed with contingency to ensure that they remain true right up to the point where negligence can no longer be attributed. Experiments, on the other hand, contain risks if they are to generate any kind of useful results. And a good experiment is actually designed to attempt to falsify a hypothesis as opposed to support it. Now, moving forward today, I have loosely collated the relationships between experimentation and landscape practice into 4 different categories, knowing very well that there are, if you all saw Karen McCloskey's presentation on Tuesday, plenty of sporks out there that span or reject this correlation. However, it is just my aim to simply produce a useful comparison for discussion, and you can feel free to throw my collated stacks of categories down the stairs when I'm done. So The first example I'd like to talk about would be landscapes by experiment. Works of this type use experiments and experimentation to bolster or fortify decisions that are made. Examples include things as common as using a digital or physical model to test out options, or building a mock-up to test the performance of a particular feature. Here you can see some of the numerical models we use to test out the configurations of our project at Illinois Beach State Park, which you'll see shortly. Another example could be the mock-up of a water wall for the Sydney Olympic Park by Hargraves and Associates. This way of working uses experiments or experimentation or experimental processes to build or develop a hypothesis that will eventually become the built landscape. The next example, but far less common, might be ideas of like landscapes of experiment. These are landscapes that serve as the context for various experiments, such as a place like the Experimental Lakes area in Canada, or a research forest like those described by Jennifer Gabrys on Tuesday. Other examples could be university field stations or vivaria and that sort of thing. The example shown here is from an experiment titled Be Forewarned, quite clever, at the Cloquet Forestry Center in Minnesota, where the ground and the air temperatures are modified along with precipitation and sunlight in order to simulate various climatic futures and measure biomass responses of the forest. In landscapes of experiment, the role of the landscape varies from that of simply a backdrop to something that can be modified for the sake of this or that experimental question. And while typically these places are designed and managed by scientists, they have proven to be fruitful contexts for landscape architectural practitioners and academics. This could be demonstrated by several design faculty working at the Agricultural Research Campus at Ohio State University, or the work being done by landscape architecture professor Karen Lutsky as part of her Great Lakes Design Lab, where she's been working through a series of design experiments that consider aesthetic experiences such as view, circulation, and ecological dynamism within the research forest at Cloquet in Minnesota. Third, my third stack here is this idea of experiments of landscapes. So this method acknowledges that there's something to be learned through a process of experimentation from the landscape itself. But the experiment itself then is designed after the fact. The most example or obvious example at least I could think of here would be looking at the Landscape Architecture Foundation's Landscape Performance Series, where a series of researchers develop assessment protocols to test the performance of various already constructed landscapes. Other possible and more strange examples could be things such as Anna and Lawrence Halperin's experimental workshops at Sea Ranch. Here you're looking at Driftwood City, or perhaps even the work of Karen Lutsky and myself as part of our Curious Methods project in the Great Salt Lake. In these cases, the landscapes of study already exist, but are then kind of probed and prodded by various experimental acts. And so let's get to this last category, this idea of a landscape as an experiment. In this example, the design of the landscape itself is the experiment. Projects of this type put their status as a landscape at risk, as opposed to the other examples where the outcome of the experiment does not actually affect the final landscape outcome because it either happened before, after, or kind of contained within the landscape. The challenge of landscapes as experiments is maintaining whatever landscape value the project provides in a situation where the landscape itself is the subject of the experiment and susceptible to indeterminacy. One way of addressing this challenge is the consideration of an experimental bracket of sorts that loosely contains the experiment within the project. This bracket could then be seen as a mechanism through which the provision of landscape values such as accessibility, habitat, public amenity, that sort of thing, is delivered while allowing the unknown to still occur as part of the project. And an example of this could possibly be the River Air project by Superpositions, which I think clearly kind of demonstrates this kind of experimental bracket. Now, I know what you all might be thinking, that honestly, every built project is subject to the indeterminacy of our world and is thus an experiment. And you would be right, assuming that you actually prescribe that mindset in practice. But however, very seldom are projects considered or advertised as experiments. Good luck convincing a community or a municipality that their new park or waterfront is going to be done as an experiment. And that's rightly so, that the needed green space for a community, for example, should not rest in the balance of some egghead speculation like some kind of landscape lab rat. For this reason, as we all know, landscapes have to be many things to many people all at the same time. And I argue that like experiments should be one of those things that these landscapes are. However, and probably most importantly, is that the risk incurred in this process must be channeled within acceptable parameters. But this isn't about mitigating or avoiding risk. It's about making risk acceptable in ways that do not reduce the landscape value in total. Now, how do we make that happen? From my perspective, there's one particular characteristic that has to be necessary at the beginning to add this idea of experimentation to a landscape project, and that's a process of integrated monitoring. Conveniently, monitoring is, of course, the focus of this session. Once an observation and response system are built into the design of a landscape, it kind of naturally shifts from the proposition of a fixed solution. And this process is something that's very nicely described by fellow Rob Holmes, toward an adaptive process of question asking and response that is likely more adept at addressing the complex situations at hand in our world today. And while all this sounds nice, there are certainly many challenges, many of which I've already described to this process. And so in order to describe these challenges and how they might be navigated, we're going to look at two projects from the Healthy Port Futures Initiative that serve at least as imperfect, but hopefully useful examples of landscapes as experiments. So for those of you that are unaware of this project, Healthy Port Futures is an initiative funded through the Great Lakes Protection Fund. It is managed by myself, Brian Davis from the University of Virginia, and Teresa Westwick, who's also here at Penn. And for the sake of brevity, I'll quickly just describe this initiative as exploring the role of alternative forms of coastal design, particularly those around ideas of sediment management that leverage natural forces to generate productive cultural and ecological outcomes for small and mid-sized port communities in and around the Great Lakes region. So the first project we're going to look at will be Illinois Beach State Park. This is on Lake Michigan, just north of the city of Chicago. Here, a highly accelerated yet still natural process of coastal erosion is destroying beach access and rare beach ridge wetland systems. This process occurs from north to south on the lake, which would be from left to right here on this drawing. That process of erosion can be seen here. This is a road that in 2019 was overwashed and kind of destroyed along the shoreline there in Chicago or north of Chicago. And you can see the rocks that were kind of added to try to reduce the effects of this process. So in response, our experiments, our kind of an experimental project, looked to see how much erosion could be prevented without obstructing the lake horizon views that are so valued by beachgoers here. And also trying to figure out how we could do it in a way that would cost less than traditional offshore breakwaters, which would be the go-to kind of standard operating procedure from an engineering standpoint for a project like this. So our project proposed a series of offshore submerged ridges made of smaller stone, designed to reduce wave energy from high energy storm waves and allow small kind of beach creation daily waves to slide over unharmed. The smaller stone that we used here was assumed to be easier to source and to place on the site. And it was also designed with the assumption that it would move a bit over time. Now, while the concept here was corroborated by the numerical models that you saw earlier in terms of the project working, and it also makes intuitive sense based on pretty simple wave physics, there are considerable unknowns regarding the degree to which erosion will be reduced and how much the feature will shift over time. So what we have is, it's not about whether or not the project works or it doesn't work, but it's all a matter of degrees in terms of like how much it works and how much how much failure could possibly happen here. You can kind of see the project, in this image, there are these kind of like three shadows on the left of the feature underneath the water. And interesting, there's a brown line kind of between the last feature and the river or the shoreline, which kind of indicates the location of a newly formed sandbar that's developed like one ridge in from the lake. And that is kind of an indication of the kind of continued longshore transport that our project wanted to make sure maintained in place. So answers to like how well this project is actually functioning will kind of come in the following years, thanks to a collaborative team of people monitoring the project. And they'll be studying it in the form of like using sonar to study how much the feature has moved, measuring wave characteristics before and after the feature with pressure sensors, and conducting surveys of aquatic life. One example here is the kind of one of the first surveys that was done by the divers looking for fish. And so here you can see a smallmouth bass hanging out over top of the feature. And below it, you can see this small PVC rectangle used to survey numbers of smaller fish. The long-term aim of the project is to develop these new baselines for adaptive coastal protection that are more affordable and sensitive to local conditions than large kind of one-size-fits-all coastal infrastructure. And now for this presentation, it's pretty easy for me to say like this is an experiment, but depending on who our audience is, there are many cases where I certainly cannot call this project an experiment. The project in many cases is understood as a pilot project or a demonstration project. And the reasons for that, I think, are kind of clear based on some of my previous kind of comments, that an experiment has this implication that failure is something that's built into it. And in many cases, these projects are designed to address a particular issue fundamentally. So we'll now move east from Lake Michigan to Lake Ontario, to the New York shore of Lake Ontario, to the small community of Port Bay, New York. I have a silly subtitle here, thinking about this whole project and everything we've done is effectively to figure out how we can move one small stone on its journey 10 feet uphill. Here again, the complex relationship between longshore sediment transport and erosion are the subject of the experimental question. The community of Port Bay surrounds a larger embayment that is protected by a barrier bar composed of eroded and transported sediment from the surrounding coastal drumlins. The channel is maintained by way of dredging through that barrier bar that provides boating access from the homes that are on the bay out to the larger landscape. So you can see that kind of image here. This is in your case, like going to the right is going to the east in this image. So we're looking northeast. And so there's an east and a west side of this bar. So to get a sense of how that landscape has changed over time, this image shows an interpretation of its kind of long-term evolution. You can see that this pier or jetty that was constructed in 1963, located right here, has essentially led to the trapping of sediment on the western side of the inlet, and then starved the eastern side of the bar. To maintain the shipping channel, dredging happens annually, and that material has historically always been placed adjacent, very close to where the material is dredged from, has been located here. And so what that has done is basically facilitated the kind of filling in or the thickening of the bar right next to the inlet, and thus material makes it here, goes into here, and makes it here, and never moves to the right, to the east. So the right side or the eastern side of the bar are starved of sediment in this system, and have gone so far that in 2017 there was a large breach here at that location. Here's a drone image of that breach when it happened. You can also see, just for some context, if we go back to the mouth of the inlet, on the right-hand side, you get a sense of how material comes from the west and then wraps around this pier and collects here in the dredge channel. And this is kind of under normal circumstances. During large storm events that come from the west, material is actually lifted up and pushed all the way over top of this pier and fills in the channel kind of just by sliding over top of it. That's what this is here. I'm standing right on the breakwater here, and the material has slid over top and fallen into the shipping channel here. This reality of kind of conditions have led to the morphology of the bar that we see today. This has been, a series of past decisions and funding mechanisms that have to be addressed. In response to this situation, we use this project to ask some questions such as, what would happen if we place material back out into the water instead of placing it into the already thickened area where it has been placed traditionally? Could waves actually move this material to the center areas of the bar that would otherwise be unreachable under the current funding mechanisms? How might different landscape forms respond to wave and wind energy? And then how could maybe this coastal landscape communicate its own dynamism in ways to the general public that are less destructive? So to begin with, and so to find a little bit of context here, so you can see this is where, this is the area where a lot of the sediment is dredged. They historically place that material here, and there's really only money from the local community who funds this project, the dredging annually. to basically move this material this very short distance. So it either kind of goes here on this side of the bar or it goes on this side of the bar. But the idea of hauling it all the way down the bar is typically kind of financially infeasible. So trying to find solutions that could address that and work within the current funding mechanism was one of the kind of goals of this larger project. Now, deciding what the form of the feature was really included a process of physical modeling that tested the erosion patterns of several different kind of formal configurations. What this process did really helped, at least it generated a basic intuition about the relationship between these different options. These are not predictive models that tell anyone what's going to happen, but they allow you to kind of demonstrate under the same conditions in the lab how different forms respond differently. And so through this kind of process, sorry, that one cut out, this is an 8-hour, these are 4 8-hour runs on the wavetable. We kind of established that this kind of shorter, fatter version made some more sense. Intuitively, it also worked better for other considerations, such as the hauling restrictions we had on site and the permitted placement locations that the state had approved. So that is what we kind of proposed. And dredging and construction were done in April of 2020 here. You can see some images of that process. So this is the channel you're seeing on the left. This is the only equipment that was used for this process. It's the only equipment that is normally used. And so the goal was to try to figure out how to make sure we could simply match the existing material or the existing construction equipment that the local contractor was using, and it wouldn't require additional materials, additional equipment, or additional funding. So that material is basically dredged out with a long arm excavator here, placed in, and then with a bulldozer was historically just kind of pushed up onto the beach in a high location. And you can see here, it's being kind of pushed out into the water, into an area where it can receive the energy from the waves coming from the northwest and hopefully move the material down system. See, look, this is what it kind of looked like from the shore. So if you're standing on the pier, you can see this is the feature being constructed in the distance. And this is what it looked like from up on the beach on the other side. So it's a big wedge of sediment, like colloquially known as the dredge wedge. So as we expected, the feature eroded. This image was taken in October of 2020. The only thing that really remains of the feature is this kind of lump of the largest cobbles that were left kind of settled to the bottom there. So you have this little bump that sticks out into the lake. Everything else has gone somewhere. We also imagined that it would take several weeks for this process to occur, and we're surprised that by a large storm that happened right after construction, the thing was eroded in about 2 days after it was placed. The project differs from the project in Illinois in some different ways. The first of this is as part of a long-term sediment management project, not a one-time thing. The construction and monitoring of the feature will occur again this spring and summer, allowing us to continue to learn about the transport processes here and also about the placement for future years that might encourage better results. The other difference is that the monitoring analysis is being conducted by our team specifically, not an outside group, meaning that we can tune the monitoring to match our information needs regarding project performance and future decision-making. The monitoring is also trying to be done with equipment that's available and easy so that once we're no longer involved in the project in 3 years, local communities can undertake it on their own. In this case, the monitoring is a fundamental part of the project. It's not something you can just unplug or release and have the project be successful. Here you can see some of the sections of the base conditions during construction and a general profile of the feature itself. These are kind of basically just permit set drawings that we did. We use drone acquired imagery with RTK ground control points to generate photogrammetry derived point clouds of the coastline, and the comparisons between pre and post placement begin to illustrate at least the general patterns of movement. We can see by dates from April to October, like the kind of movement of sediment, or August here, the movement of sediment, or at least the movement of the shoreline outwards, was one way we used to assess the kind of effect of the feature. Others were these point clouds that looked at basically cut and fill from one point to the other, were areas where elevation changed one direction or the other. We also use photo points to corroborate that sediment was in fact increasing in the thinner locations of the barrier bar after the feature eroded. But of course, we need to be more certain about the kind of cause and effect that happened here. We need to do this over a couple of years to ensure this isn't simply just a statistical anomaly. So here you can see several of the kind of non-text pages of an elaborate monitoring plan that is part of the project. And that this includes kind of when we visit, what parameters kind of require a visit, what transects will be done, that sort of thing. Now, the ability for this process to both address dredging needs and strategically reintroduce sediment back into the longshore system is something of clear interest and value to communities along the shoreline, and is already being added to the county's approved list of dredging strategies to be used in other locations. Our continued monitoring will establish a more detail of the beach composition produced through this process and the relationship between wave energy and erosion rates. All along establishing a highly temporal indexical marker of coastal process on this public beach. So to conclude, I would simply say that I strongly urge for the expanded use of experiments in the practice of landscape making. And while this ask runs counter to the "I'm always right and never mess up" attitude of professional practice, the built landscape provides an essential opportunity to learn about our uncertain world. Finding ways of working that do not avoid risk, but challenge it productively towards acts of knowledge creation while still delivering on our promise to society and the environment as a whole should be one of our central objectives. Because if we get it right every time, we'll never learn anything. Thank you.
Strong kickoff, Sean. Okay. Thank you. So Monica, Chasten is next. And if you want to share your screen, that would be great.
Okay, can you hear me and see me?
Yes.
Yes, we can.
Yep.
All right. Well, I'm truly humbled to be here as a government employee. I've been listening in on the last few days of the symposium and have learned a ton, and hope to share some of those lessons learned with the work we're doing. But I'm very, very excited to show you some of the work that we're doing in the Corps of Engineers. And thanks to the organizers for having me. So I have the obligatory Army slide and Army slide template through the rest of this talk, but I just put up here a few, fun facts relative to the Army. If you're not familiar with the Army Corps of Engineers, we are predominantly civilians. We do answer to generals and colonels, and it's a fairly regimented system in terms of working for the Army, but that's always been the challenge to me. I've been working for the Army Corps for 36 years now. Started out in our R&D lab in Vicksburg, Mississippi. Anna mentioned it was ERDIC. You'll hear me mention them throughout the talk. And really trying to take a creative approach to the work we're doing in the coastal zone. That's again, been the true challenge for me throughout my career. We do need two things to do a project. The first is the authorization or the law. So we can't just go out and do a project anywhere we want. We need Congress to authorize the project, and then we need the appropriation, which is the money to do it. So two basic things, but two pretty big things. You can have a project authorized, for 100 years, but never sees money, so it never gets built or maintained. On the lower right, you can see the Army Corps breakdown, and you'll see us in Philadelphia district there in blue within the North Atlantic Division. But we really share lessons learned across the Corps, especially in the field that I'm working in. So where I'm going to be talking mostly about the coastal zone, we do have similar programs and share lessons learned across the fluvial projects that we have too. So I am currently a coastal engineer, but a project manager for the Corps' navigation mission in the Philadelphia district. So I manage coastal navigation in New Jersey and Delaware. And you can see on the right side, the blue lines are all of the navigation projects that we have within the Philadelphia district. So my job is to keep the channels that I manage clear of sediment and keep navigation safe throughout those channels. Our largest project is the Delaware River. My largest project in the coastal zone extends from Manasquan Inlet 117 miles south to Cold Spring Inlet, and that is the New Jersey Intracoastal Waterway. So I've started using this slide in a lot of presentations, and the quote came from one of our partners, Dr. Lenore Tedesco of the Wetlands Institute. And core dredges a lot of sediment. You saw it on the last slide nationally. That sediment in the past has really been demonized, called spoils and seen as debris. But that sediment is coming off the marshes and the shorelines where we're working adjacent to. So really, if we flip the way of thinking about that sediment, it's seen as valuable or asset, or as Dr. Tedesco said, the currency of the marsh ecosystems that she works in. If we can take that analogy, the Corps can then be seen as a sediment broker. For state navigation channels, the state is the sediment broker. I like to think of myself not as just someone who's supplying the sediment, but working within that system and really using my coastal engineering background to work across the different business lines. So our challenge to change practices within the Corps is how can we improve our stewardship of the sediment or the currency that we're working with, and look at overall coastal system analysis. And I put, our traditional design, planning, permitting, construction processes up there. We are looking to change aspects of all of them. And I think where we are making progress right now is in the construction, monitoring, and adaptive management phases. Again, we work pretty regimented. In the case of our projects, some of those designs are on the back of a napkin, and we're just going and building and then monitoring and adaptively managing them as we go. So I have a persistent approach here, past, present, and future. And I use the word persistent because we've been talking about making some change for a long time. Our district in particular has been part of the Regional Sediment Management Program in the Corps of Engineers for the last 20 years. But it wasn't until a major storm like Hurricane Sandy impacted the area that people woke up and really accepted the fact that we had to stop talking about things, accept some risk, and really make a difference in the work we were doing. So we set off using the technical expertise we had through our ERDIC lab in the RSM and the Engineering with Nature programs, developed short-term strategies to kind of get us past the recovery portion of Hurricane Sandy, but then launched into long-term strategies to really make change in terms of the practices we're doing. And in 10 short years, we've really changed a lot of the way of thinking of the resource agencies and the states and the communities from being risk averse to dredge material to really being proactive and innovative in how we can use it. So some of the work that we're doing in the Corps, I think we can then share with the state and locals. We have the ability to make some change, and then we can share those lessons learned and maybe keep that change going to other communities. RSM, Regional Sediment Management, as I mentioned, our district's been a district participating in this program for 20 years. It's managed out of ERDIC, so our R&D lab. We think in stovepipes or business lines. So as I mentioned, my role is in navigation. For 15 years, I did beach nourishment projects in our engineering division. That's another stovepipe or business line, but that business line, every grain of sand that we put on the beach is valuable. Where in the navigation program, we were just throwing it away. And then the third business line being environmental restoration. So really just trying to change the way we're thinking and do better things with sediment management. Engineering with Nature is another newer program, also managed out of ERDIC. Dr. Todd Bridges is the program manager for this. Many of you may know him. He's really done an amazing amount of work in terms of collaboration, both nationally and internationally. And our district was one of the first 3 Engineering with Nature proving grounds. I believe there's 6 now. That being a part of that program and being a part of the proving ground has really launched the work that we've been able to do and the collaboration that we've been able to accomplish. So my first exposure to landscape architecture was actually through the EWN proving ground, and the Dredge Research Collaborative and Sean and others were involved with a study that was done through the EWN program for the New Jersey Back Bays. And this was done for a planning study that's looking at hard structures, big engineering structures. But how can we look at natural and nature-based features and look at the landscape differently in terms of providing flood risk management alternatives to those big structures? So through this study, but also through some of the work that we've been doing with the EWN program, I've really started to visualize things different in terms of the landscapes we're working with. And I have to thank landscape architects for that. Our program has really progressed from confinement. So the upper left photo is a confined disposal facility, or CDF. And I think it was Dr. Bridges that mentioned it looks like we were trying to build temples to the gods on the marsh. So if you're driving down the New Jersey Parkway, you'll see a big mountain rising off the marsh. That is a big bowl with berms where we were just disposing of our sediment. So taking it out of the natural sediment system and throwing it away. I moved into this role 10 years ago and really have been trying to progress from that practice to in-water creation of projects, keeping the sediment in the system, where we had pictures here that were portfolios or pictures from other districts. We now have our own portfolio of projects. I'm going to quickly go through that. I figured I'd show you some of the work we're doing, and then can address some things through questions. For all of these projects I'm going to be showing you, we are monitoring. So rather than call out the monitoring and the adaptive management we're doing for each of them, I just wanted to show you the projects, but realize there's a ton of monitoring going on in each of them. This slide is showing the easy ones first. So if we have sand in a channel that connects the Atlantic Ocean to the back bays, that's an easy one to work with. Anything greater than 90% sand, we can take it back to the beaches. And we have almost 90 miles of federal shore protection beach nourishment projects along the coast. So we take it out of the navigation channels where we don't want it. We typically use the government dredge you see in the middle where the hull opens up, and we can release it. This isn't something we typically monitor, despite what I just said, because this process is more like nourishing a garden. It's fertilizing the system. It's small bursts of sediment where we let the natural waves and processes move it on. And if we're doing it right, and we haven't designed it to be a fixed structure, then you won't even see it. It'll just be part of the natural landscape, natural processes. So some of the more challenging projects, moving forward from just pilot projects after Hurricane Sandy to really standard practice and a system of solutions for the rest of our coastal projects. I wanted to just highlight 3 of the original ones. And you can see here, the reason I called out the sediment type is one project, Ring Island and then Great Flats, was working with all sand. Mordecai Island was a mixture, and Avalon was completely fine grained material. All 3 of these projects were along the New Jersey Intracoastal Waterway, that 117-mile long waterway that I mentioned earlier. So Mordecai Island is our poster child for RSM, best RSM practices. The blue line on the left is the New Jersey Intracoastal Waterway that passes behind Long Beach Island near Beach Haven. And Mordecai Island was an island that our planning group had actually been trying to restore for ecosystem restoration purposes for 15 years. Past practice for navigation was to place the dredge material in that tiny little CDF called Parker's Island. We were sharing that with the state and locals also, and nobody had room for their dredge material. So at the same time, we're trying to do an ecosystem restoration project, and it was kind of a no-brainer. You can see in the right photo where the dredge is working in the channel, and we're pumping directly onto the 2 portions of Mordecai Island, trying to reestablish that island and eventually create habitat. So I mentioned a no-brainer, but through the EWN program, we really developed this project into a collaborative approach to using dredge material that launched so much more. And we were able to get this project into the Dutch Dredging Museum and the Engineering Nature Atlas, and it's really kind of launched a lot of the work we're doing. Another pilot, which groundbreaking again because it was fine grained material, was doing thin layer placement on a marsh in coastal New Jersey in Cape May County near Avalon. This took multiple trials, experiments, if you will, based on Sean's talk, to try different approaches. How can we move this dredge material and only place it in what some were calling a thin layer, but 3 inches to 6 inches. It was hard to do from a technical standpoint. So we did it. We tried different ways to do it. We're not done completely. And that monitoring is still going on in terms of the success on the marsh. Another one of our first projects was Ring Island, where we took a whole bunch of sand and built a big berm, big island on top of a degrading landscape. This project is right near the Wetlands Institute, and they continue to monitor. It's been very successful in terms of the bird usage in this area. And we've also gone in and sculpted it, so adaptively managed it and figured out how to place just a little bit more material on it to give it an uplift. So this is part of one of our systems of solutions. In the future, from what we learned there, we're carrying it forward to other projects. These were the easier projects, the pilots, the first ones off the ground, but we were really left with some of the harder questions. How do we scale up? How do we use more fine-grained material? How do we really clear these channels instead of just clearing part of them? I was fortunate enough to attend one of the international guidelines meetings, met a contingency from the Netherlands, and their suggestion was, well, when we get to the hard questions, we created something called a living lab. So it's a collaborative forum, a culture for collaboration where people can bring their concerns and their questions, and we can throw science at it. We can monitor, we can do some trials, and we can really start to get at some of those harder questions. It's a partnership right now. The co-leads for the 7 Mile Island Innovation Lab, or the SMIL, are the core, and that's the Philly District and ERDIC, the state of New Jersey, and also the Wetlands Institute. And as I mentioned, this was a concept that was inspired by the Dutch. I would encourage you to Google the website at the bottom, or Google Living Lab for mud, and you can read more about what they're doing. So the 7 Mile Island Innovation Laboratory, the real cool part here is that there were past placements in the area between Townsend's Inlet and Hereford Inlet in Cape May County, where we had dredged material and just thrown it up onto the marsh. And those are the only good habitat left in this part of New Jersey for a lot of the nesting birds and shorebirds that are using this area. So we can learn from the past. We have a CDF in there, we have beach fill on the ocean front, and we have a navigation channel that bisects the entire area. So we set off really trying to build some more projects, build some more experiments, and the Wetlands Institute, being right in the middle of it, is doing a lot of the monitoring for it, along with 10 different groups out of ERDIC that are doing different types of monitoring. This was our first one out of SMIL, again, looking at a system of solutions where we had so much success for Ring Island. We found another degraded portion of the landscape, a marsh, where we wanted to build additional bird habitat. This one, we knew a little bit more. We were able to use the lessons learned. Less containment. We used the natural pools on the marsh to contain some of the sediment. We brought in some hay bales, but we really didn't even need that. And one of the coolest parts to me about this project is I'm not sure if you can see my cursor, but when we originally dug the channel over 80 years ago, we threw the material up on the marsh, and that is the only piece of high marsh left in this area. So now we're taking it to the next level in this mill. There are 2 islands, one of which is owned by the Sturgeon Island, is owned and managed by the Wetlands Institute. The other island, Gull Island, is, you can see in the lower picture, almost underwater at high tide, and that's part of the state's Cape May Wildlife Management Area. So we are really now looking at how we can reestablish those islands in the face of climate change and sea level rise, and what types of projects we can do, learning from what we've done so far and also the past. This slide, you can see Tim Welp, who unfortunately passed away in June. This was his baby. He came up with a technique called the sediment distribution pipe, and we did several placements with the pipe in March 2020, and then again in the fall, following fall, to learn more about how we could spread sediment across the marsh. So we're in thin layer placement. We had one pipe coming out and spraying the material. This one is spreading material across the marsh. We tried it elevated on the marsh, and in the lower photo, you can see we're trying it to build edge protection. several different layouts. Our ultimate goal is to try to build elevation on Sturgeon Island, to build habitat on the north side and equate that with the good habitat that is also starting to degrade on the south side of the island. This project, Gull Island, I'm so proud of this one. This was big for us. So in the middle of this picture, the southern part of Gull Island is kind of the landfall for the dredge pipe. We tried several different techniques here. We had a sprayer and a spreader and a Y valve that split the dredge material. But the cool thing here is that we let nature do the work for the material. So where Avalon had containment, and it was actually over-contained in our opinion, we let the channels and the landscape do the work and move the sediment here. And it's so far so good. It's had unbelievable, nesting birds have showed up on this, and we're monitoring all kinds of components of Gull Island. So my advice here, don't over-engineer, don't over-contain, let nature do the work. That was what we learned between what you see here in Avalon and the marsh that we restored, and some of the containment that was used, extensive containment throughout the marsh, to Gull Island, where we didn't put all that out, and we were even more successful just by using the landscape. As I mentioned, ton of monitoring going on. More than I could put on this slide, more than I can talk about, but I had to get Keith and Sean in this picture. A lot of sediment work going on, a lot of dedicated people coming up from Erdic, going knee deep into that mud, but really exciting. We're also working with Boston College on some of the monitoring moving forward. So just a few more slides. I say building momentum because we went from pilots to the work going on in SMIL to some really big initiatives that are coming up, scaling up. And then we also received a ton of infrastructure money to really, I think, start to make a difference in terms of beneficial use and adaptive management and the science behind the work we're doing. So last August, and then the previous fall time, we finished 2 phases of the Water Resources Development Act, Section 1122 pilot that we received for Barnegat Inlet, one of only 10 pilots across the country. And we are the first one out of the gate. So we actually built this in 2 phases. The left side was an intentional island creation site. And I say that, I'm going to show you a slide. We built 2 islands unintentionally that are now fantastic habitat, and the resource agencies don't want us to use them. So this time we wanted to intentionally build it, learn from it, and figure out how to do it better. On the right side, we used the government dredge Murden last summer, 42 days of dredging out of the inlet channel to create a perturbation or a nearshore nourishment in the shoreline around an erosional hotspot that we had in the federal beach fill. And now we're monitoring that both in terms of waves and movement of that nearshore nourishment. So I mentioned in a previous slide that we had 2 other islands in Barnegat Bay. The left is a LiDAR photo from 2013 of all the sediment that's moving behind Barnegat Inlet. So it's real sediment-rich system. Bernie Moore was someone that created the Division of Coastal Engineering in the state of New Jersey, and he was a pioneer. And I was lucky enough to find a record that said he created a dredge technical committee that ultimately led to partnering with the other resource agencies in those 2 islands. But they were never monitored, they were never documented, and they began to be called disposal islands. So again, words matter, and they went from beneficial use islands to disposal islands, and that turned the way we were looking at these. So we're trying to learn from what we did in the past and created that new island, and we're monitoring all 3 now in terms of climate change impacts and how we want to keep the habitat going. Systems approach to beneficial use for Salem River. This is a big one. Actually, the dredge just got to the lower left photo this morning. We have the Murden dredging a portion of that river. It's never been done before, and they're taking the material over towards Oakwood Beach. This is our first move towards supporting larger rivers and also some economically disadvantaged communities where the sediment is really, really important in terms of flood protection for them. We're modeling this. We have a little bit more time. We're going to take the larger part of that material from Salem River, the fine grain material, over to U.S. Fish and Wildlife Services, Sapana Meadows. It's a national wildlife refuge. So we're working on understanding fine-grained materials better and modeling that before we go do a placement of probably about 150,000 cubic yards in Sapana Meadows. One of my last slides, I wanted to highlight this. I'm so excited about this project. This was the first time that we've received a project like this in an actual president's budget. So we got money in the FY22 president's budget. This is one of the projects that got authorized in I think it was the early 1900s. It's only been dredged twice. A community that is losing shoreline along the Delaware Bay at unfathomable amounts of shoreline erosion, and an economically disadvantaged community also. So we were able to get a good chunk of money in, and we are working with Sean and Keith and Karen now on some of the pre-placement monitoring. One of the things I'm most excited about is we're not just going to look at this like we typically do in some of the other placements, but really bring in their expertise as landscape architects to do a placement that fits this community and gives them the attention that they deserve and that they haven't had for years. So last slide, in terms of some of the things we're looking at, we have to embrace that change. The status quo with climate change is no longer an option. Places like Gull Island are going underwater. So even though we've made rapid progress in the last 10 years, we have a lot of work to do. We are getting a lot of support from the upper levels in this current administration to do a lot of beneficial use. General Spellman, who's our chief of engineers, set a bar of 70% beneficial use for navigation, clean navigation, channel sediments. We're setting our bar at 100%. Partnerships are key to long-term sustainability, also potentially policy changes that after I retire and others retire, we keep this momentum going. Working across cross-disciplinary teams, I think, is really important. I can visualize something one way, but a landscape architect or a biologist will see it differently, and really working those teams has led to some of the successes that we have now and that we'll continue to have. The importance of monitoring for adaptive management. What we're learning, we might not always get it right, like Sean said, on the first try. So how can we do it better the next time and improve on that? And that way, that builds a lot of trust too in the work that we're doing. And finally, one of the quotes that was really from somebody that didn't know anything about what we're doing. He was the colonel of the San Francisco district, and we were talking about all this work. And he came up with this quote that adaptive management puts controls on known risk. So in the beginning, where everybody was risk averse, we really have started to communicate more about monitoring and adaptive management now, and that we can accept some risk and evaluate that and then adaptively manage it as we go. It's a change of thought process for the Corps of Engineers, but I think we're getting there. So I want to thank you for your time. I just want to show this slide as this is the next big initiative I'm working on. This is the Government Dredge Merit home ported out of Wilmington, North Carolina. And I think this is going to be our solution for more of that nourishing the garden, where we can dredge the channel and really supply material to the system in such a low impact way that it'll let nature do all the work. Thank you very much for your time.
Great. Thank you, Monica, for sharing that work. It's thinking on the big scale there. Super exciting. Okay, so next we have Iryna Dronova. I'll hand it over to you.
Hi, everyone. Thank you so much for inviting me to speak today, and many thanks to the organizers of this exciting series. I'm Iryna Dronova from UC Berkeley, and I would like to start with a little story. Every fall at Berkeley, I teach a large undergraduate course introducing environmental science to landscape managers. And I often first show my students this map of global terrestrial biomes shaped by climate, vegetation, topography, and I ask them, what is missing? And usually somebody would first say oceans. And I would say, well, yes, oceans are very important. They seem to be missing from here, and this map kind of emphasizes land. What else is missing? Then they take a look again, and somebody would say cities. And then someone else would say agricultural fields, people. And then I show them another map, this idea of anthropogenic biomes coming from the group of Professor Earl Ellis at the University of Maryland, where the categories show various aspects of human presence and effect of landscapes long before modern era of remote sensing and monitoring tools that we have. And the reason why I like showing this example is that our local and global landscapes have a lot of ecosystem forms shaped by human activities. Many of them are experiencing novel types of change with shifts in climate, land use, human populations. And we're also actively learning to change the landscapes intentionally to improve, mitigate, restore, create benefits for people in nature, as has been also discussed by earlier speakers. And monitoring this change becomes very important, both to understand whether our original goals are met, but also to be able to track unexpected changes, know when to intervene and adapt. And as has been also discussed earlier, remote sensing technology has become very attractive as a monitoring tool, thanks to spatial coverage, possibility of repeated observations, especially from satellites, but also with newer technology that's more customizable, such as unpiloted vehicles, drones. We also start seeing greater spatial detail, opportunities for visual recognition and flexibility of application. And when we also have longer archives of data from various types of instruments, we can look into change in a more nuanced way. And we can look in both short-term and long-term changes and start trying to guess at the process behind the pattern. But it is still very important to recognize that even the most advanced sensors cannot really tell us about that process directly. Interpretation of the process behind the pattern still remains our job. And this job does require linking this top-down monitoring capacity with bottom-up knowledge, ground observations, and models. And today, I would like to share with you a couple of examples from areas closely related to my work at UC Berkeley that illustrates both the needs and the opportunities for connecting this top-down and bottom-up understanding. The first example concerns what is truly a real-life experiment. It's a novel and expanding model of wetland restoration in our California's Sacramento-San Joaquin Delta. This is the region northeast of the San Francisco Bay, at the confluence of Sacramento and San Joaquin rivers. Historically, this was a marshland, then converted to agriculture for most of its parts. And that conversion led to erosion of the organic soil, as a result of which many parts of the Delta landscape are below the sea level at the moment, protected by levees. So people who work in the Delta often take these photographs of a ship passing by in a channel, and it's so high, the water is so high that it appears to be almost floating in the sky. But what this means is that there is a massive flooding risk for the ecosystems and communities who live there because of both this ongoing land subsidence and the sea level rise threats from the climate change. And this has stimulated a lot of interest in wetland restoration. There are massive restoration efforts in this particular region and also in the San Francisco Bay. A lot of them historically have focused on habitat and biodiversity goals. But now there's also a growing interest in using this wetland restoration towards helping to sequester carbon and greenhouse gases through the high productivity of wetland plants and soils. And that can also allow rebuilding the soils through this productivity to help accrete the levels and counteract this flooding risk and subsidence processes. A number of agencies are very interested in this. Right now, the efforts I'm going to talk about are led by the California Department of Water Resources and their partners. So they're testing this new model of wetlands that are essentially meant to be gigantic carbon farms. Usually they're initiated by flooding of former pastures or agricultural fields. They can be prepared by grading or sometimes by additional engineering of some bathymetric complexity. And once they're flooded, vegetation starts coming in and colonizing, and over time, plant patches expand and start gradually filling up the site. There's often no particular design for vegetation other than the design of this kind of site berms and this initial structure. But one of the species of interest is tule or hardstem bulrush. It's a native wetland plant that used to be very popular in the region and very prevalent and was widely used by the Native Americans in the region for various purposes as well. What is interesting about these wetlands is at the moment, they're highly managed. they receive water from the nearby channels, but they do not yet experience tides. So they're still accreting towards that. And that effectively makes them novel ecosystems, which raise a lot of questions of how will they change over time? What factors most strongly affect the rates of their plant expansion? Once they start filling up, do they continue capturing carbon at the same rates or not? And to answer these questions, we can no longer rely on just field observations, which are very difficult in wetlands. We can look at some facets of their change through remote sensing, particularly very high resolution imaging repeated over time that can capture very nuanced details about patch configurations. But also when it comes specifically to these carbon-related goals of the projects, we have to also think about what happens inside these patches and inside these canopies. A very interesting aspect of this vegetation is that they tend to accumulate a lot of dead biomass because they do not experience tidal flushing yet. And this litter buildup can be very massive. It can also highly vary in space. And it creates this very interesting suites of feedbacks where buildup of litter blocks light penetration, which then reduces the opportunities for younger plants to grow inside these larger patches, it reduces their green biomass, and it reduces how much carbon they can accumulate over time. But that doesn't become conserved over time because this litter gradually buries and goes through cycles of buildup, collapse, and burial. These feedbacks are very important for understanding the outcomes of restoration, particularly this goal of carbon farming. And we have to tackle them from very different perspectives. Some idea can be provided by field measurements of plants and looking at the canopy structure, heterogeneity of presence of dead biomass and changes over time. Like I mentioned earlier, it's very laborious and difficult to do this on a massive scale, particularly given limited mobility in wetlands. When possible, we can engage LiDAR sensing from light detection and ranging technology. Aerial LiDAR, as you can see in these profiles on the right, can be very interesting in elucidating these structural differences. For example, younger patch edges where there's a lot of green plants, but also relatively sparse. And so the LiDAR signal can go all the way through versus some of the older ages that have so much litter that in some places the LiDAR cannot even reach the bottom of the substrate. And so that can give us an idea about how structural properties vary across the whole site. Although LiDAR still remains somewhat expensive and the opportunities for acquiring such data do not come at a regular kind of temporal frequency. So when available, they provide this idea. But we can also develop collaborations with scientists who study carbon fluxes on the ground. Here on top, I have an example of a measurement station by my colleagues at UC Berkeley's biometeorology lab. And scientists who measure carbon and greenhouse gas fluxes collect a lot of other important data that can really help shed some light onto what is really going on behind changes detected by remote sensing. For example, data on microclimate, data on specific timing of when carbon uptake by plants is increasing or decreasing. And one of the interesting results, just as an example of this collaboration in my research, was that from remote sensing data, we detected substantial variation in seasonality of plants or phenological cycles. For example, we can see that the timing of spring green up can vary by several weeks, even within the same vegetation type. And that raises this question whether this is due to litter obstructing green plants from the satellite's view, or whether something else is going on. And by incorporating field data measured by the meteorology group, we can see that it's not just the obstruction. The actual cycles of these plants are also delayed by presence of litter because it contributes to cooler microclimate and lower canopy and water temperature. These kinds of understanding and insights are really important for broader knowledge of what drives these carbon cycling in the systems, how their annual budgets of uptake and release of carbon is shaped. And so from developing such collaborations between remote sensing and field knowledge, we can really more mechanistically understand post-restoration dynamics. This also raises very interesting questions for management, whether there should be any interventions, how can initial design of these sites be factoring these processes into account and maybe steering wetlands in a certain direction. We now also have evidence in the region that Native Americans did some burning in these wetlands as well, which could be another management strategy. And again, many other interesting questions from here. Now I'm going to shift gears and talk about the second case study, which concerns the issue of urban heat. You all very well know that urban warming is a major threat to human well-being in growing cities worldwide. It's a huge social and environmental justice issue because opportunities for cooling and mitigation are often not equitable, and the risks are also not equally distributed within populations. And also, very importantly, even though urban warming can be amplified by climate change, it primarily results from how we design and build cities, properties of the built environment, removal and fragmentation of green spaces, water, and so on. In other words, even if we could stop global warming, we would still not necessarily stop urban warming, particularly as cities are still growing. Again, remote sensing has become a very important tool in urban heat studies. Some instruments have thermal sensors, which can measure proxies of surface temperature and show us how it changes in space and time. We can connect this to various aspects of land cover and land use. For example, many studies have shown that large vegetated spaces or water bodies are often substantially cooler, and their cooling effect can also spread over larger distances to surrounding areas compared to smaller, more fragmented green and water spaces. We also have massive progress in computing tools. This is just a screenshot of a kind of a working process in Google Earth Engine, which is a cloud-based programming interface that allows us to connect to publicly available archives of satellite data and other geospatial data sets and do the processing in the web browser without having to download, process, and store these data on your own computers. And this significantly saves the time and allows us to jump to testing these ideas right away. And what this potential also gives us is opportunities to work with more than one data set at the same time. Here I have an example of what I call coupled thermal greenness metrics. If you look at the very right here, every pixel in this image shows how that pixel is cooler, hotter, greener, less green compared to the average in a given area, such as a city. And you can see that even visually, these patterns correspond to certain types of land use or land cover that we can recognize from the aerial photo. We can also summarize the counts of these pixels within a city and say, okay, what proportion of a given region falls into this hotter, less green category or cooler greener, and how that changes over time. To give you a few examples of this is a residential development in Dallas, Texas, in a peripheral area where a rangeland was converted into a new development. And we can see just visually, again, even from this metric, that areas that were predominantly greener, whether cooler or hotter, now shifted to predominantly hotter and less green. We can also work with spatial summaries of these metrics to help connect them to other clues about what might be happening due to policy planning and so on. Here I have an example of two capital cities, Kyiv, capital of Ukraine, and Beijing, the capital of China, both of which transitioned into market economy from the early 90s. And that transition was accompanied by massive urbanization. And if you look at the Kyiv here on the left, you can see that a lot of it probably involved some erosion or some grabbing of green spaces and led to reduction in these cooler, greener zones over time. Beijing, however, was implementing massive greening programs and had a lot of turnover of green space, but also a lot of new green space created. And we can see that this hotter, less green portion of the city actually eroded over time, and we see some buildup of their cooler, less green spaces. We can even take this thinking into a more short-term framework, because remote sensing data sets are often snapshots. We can ask questions like, how do these patterns change on a seasonal scale within a given region, particularly a region with very dynamic microclimate, such as East San Francisco Bay? So we can basically develop this from time series of satellite images for different times of the year, and they can capture massive transitions, such as, for example, spring green up, as you see these large chunks of green when annual grasses are green before they die around May or June in our region. But you also see times when the whole city suddenly becomes cool after a fog spell, telling us something that maybe was a very snapshot pattern in the remote sensing data set. So all of this is very interesting for detecting hotspots and informing us where maybe the opportunities for interventions lie or whether we might be thinking about mitigation. But when it comes to real world cities and real people living in them, our capacity to experiment with solutions can still be limited by the risks of the unknowns. And so to develop this bottom-up understanding of these factors and their drivers, we can also engage modeling tools. And in the context of urban heat, a number of interesting tools have started to emerge, and more of them are being developed probably as we speak. Some of them are better suited for local site scales. Some of them are better suited for looking at the neighborhood relationships. I'm going to give you a couple of examples using NVMat software, which is meant to be more of a site scale application that allows you to model urban environment and vegetation properties, materials, surfaces, even create your own materials or plant types, and use that to simulate how this design would affect local atmospheric temperature, humidity, wind speed, and other important parameters. Here I have an example from a study that was led by our landscape architecture graduate student, now an alum, Ian McCrae, where he designed various scenarios for extreme heat mitigation in a portion of a commercial district in the city of San Jose in California. And he did this in NVMat, again, at the very local scale. And then he also connected it with a top-down urban climate model developed by colleagues at the San Jose State University that predicted the scenarios themselves and the potential extreme heat. And that other top-down modeling approach actually required also remote sensing input of a land cover classification that would be more realistic about urban types of land cover and land use compared to popular remote sensing product. And that was also developed as part of this study. If you're interested in more detail, the study is available in open access. It was published in Building and Environment in 2020, and here is the link. I've also tried using this tool in the Landscape Architecture Studio, where the students combined heat mitigation ideas for a public park, kind of Madison Park here in Oakland, and its neighborhood with various other needs for social, cultural, and other services to the local population. And the idea of this site was inspired by an earlier remote sensing study that highlighted this part of Oakland as a relatively warmer in our region, which has a lot of parks that are relatively warmer compared to other parks and are surrounded by relatively warmer neighborhoods. And using NVMat in this context for both site and sort of neighborhood scale analysis led to some really interesting discussions and thinking with the students. For example, they had to learn how to simplify design ideas to make it work in the modeling tool, but without losing critical detail. We talked a lot about understanding landscape constraints on heat mitigation. We cannot plant forests everywhere, and there are a lot of needs for social space, particularly in the low-income neighborhoods, which would not work well with putting trees everywhere, where people need sports grounds, access to certain playgrounds, and other not necessarily vegetated types of land use. We also talked a lot about how the design ideas might have to spill outside the site and take a better advantage of the surrounding street fabric. And lastly, this kind of idea of design prototyping, right? That even though the sites are unique and always have unique complexity, we can also think about scalable models, distributed solutions that could be replicated across neighborhoods, and then together adapt to these broader scale mitigation strategies. So in summary, both these case studies highlight the importance of thinking across scales when developing monitoring strategies. Remote sensing certainly offers a huge support for monitoring change, particularly when it comes to novel ecosystems and novel types of change. To develop robust understanding from the monitoring what really drives these change patterns and applying it to decisions, we need to also really strongly engage collaborations, field surveys, and modeling efforts to develop this mechanistic bottom-up base for these solutions. And the time for this is extremely ripe with all these developing tools and novel opportunities for communication. I'm going to stop here. This is my contact information for anybody who might want to reach out later. Thank you again for being here, and many thanks to the organizers again. Thanks.
That's great. Thank you, Iryna. All right, so we've got one more presentation. Brett Milligan. We're going to stay on the West Coast, I think, in the same Bay Area region. Take it away, Brett.
Hello, everyone. Nice to be here, and thanks for the opportunity to share our work. Hopefully everyone can hear me and see my screen. Please speak up if you can't, because I can't see you. I'm going to be focusing just downstream from that last presentation in the Baylens of San Francisco. Baylens are more or less defined as the space between high and low tide at the land-water interface. And this is an image of one area of those Baylens of a mud flat, as you can see, full of trash. And I'm going to position the Baylens as a type of ruin. There's lots of ways of defining a ruin, but thinking of it in the way that anthropologist Anna Tsing has, that the ruin has become our collective home. We are surrounded by ruins and miscellaneous design failures, including what we've done to our climate. And trying to have curiosity and openness through this. If you accept that progress is a myth, how do we start to take curiosity about what's been left to us as the world we have today? So this is another image of the bay. You see the tires just everywhere as a condition. And I also see the bay as a ruin in making. It's not yet ruined, but it's likely to become, like these mud flats are likely to go away with climate change and just become open water. So they're sort of in the process of becoming a ruin in a larger scale and a climactic change. But what is the experience of being out in places like this? These are the mud flats. I think the mud flats are generally under considered landscapes. There's a lot of focus on marshes because they're vegetated versus the mud flat that has, it's mud. And I have a particular interest in mud. And in particular, designing with sediment, one of the biggest problems the bay faces is a shortage of sediment supply, like many bays and deltas around the world, where upstream infrastructure often have the amount of sediment supply at a time where you need more sediment than you ever maybe did in the past because of climate change and needing to accrue elevation. So most of the sediment the bay gets is not from this huge Bay Delta watershed that covers about half the state. It more or less just comes from the small tributaries that come into it, just surrounding from the hills. And this is one of them. And you can see this creek, highly modified by 1960s era Army Corps flood control systems. And you can see this particular creek is definitely bringing sediment into the bay. And there's a lot of questions of how much or how these are actually working as modified systems and how much they might be able to contribute to climate adaptation in terms of how much sediment gets down there. So I got very curious about this and wanted to figure out a way to monitor it. And if you look very closely in the image, you will see a grid that hopefully, the next image shows right where you see that kind of mini delta forming where it branches out. So if you see there are all of these tires scattered around or in array right here. For sense of scale, that's me off to the left. And I tried to space these out 50 feet apart as a way to try to monitor what might be the flux of this landscape. There's a diagram of that, and you can see all of the tires laid out there. I did these all without technical instrumentation. I did it by an embodied way of doing it. I just tried to lay them out, pace them out 16 paces and tried to lay them out. And I tried to get it exact as I could, but for the sake of the experiment, it didn't really matter as long as I knew where they were, because I was going to then monitor them using a drone in X, Y, and Z planes to see how they moved or were affected being out here. So it's sort of a way to monitor the landscape. You can see here in short time scales, looking at how the tides over 2 hours move across it. And but also looking at longer term change, such as taking repeat drone imagery surveys, using photogrammetry to create really fine-grained digital elevation models down to centimeter or millimeter accuracy. So where I could start to see change happening as it does, whether that's how people inhabit this mud flat, if they do, how the tires are responding to being out there. I don't know if you can see the grid in there or not, but it's there. And then you can see at the top, that's the mouth of the creek. And when I put this out here, I had no idea what was going to happen. I don't know if, when a storm comes in, if it's going to just blow the tires out or if they'll stay in place. And that's part of the experiment, to see how they move, or if sediment is accreting here and to what degree, and does it, after it accretes, does it go away and get drift around the bay? And so the grid's a way of doing that. And you can see the grid a little bit easier here. From the air, it's easier to see. But part of my experiment here was cultural and aesthetic as well. Of, I was wondering, if I arrange these tires, would anyone even notice they're there? Because if you look back in this image, there's still plenty of other tires scattered around my grid of tires I couldn't move or just didn't care to move. And in some ways, I didn't want it to be visible. I want this to be a grid that I can use to monitor change. There was also a little bit of subversion of scientific protocol here, where if I had gone through a process to permit me putting in a survey grid on the bay, that probably would have been quite cumbersome. So instead, my technology here is a reconfiguration of garbage tires that was already there, that I just put into a different order upon the landscape and tried to use it. And the idea is that not just immediate change, but these longer term differences, and seeing how the landscape is affecting the grid, as you see on the left there, that the tires are moving out of alignment, and how those tires over time are getting colonized by different things. And as an example, you see this one tire here. It's a peculiar tire that I used. It's very wide. You can see that track of how it's moved across the slide. And at first I thought a person did this. I was like, oh, they must be using this as a chair. People come out and fish. And again, this is the grid getting moved around. And then by studying it more, I think it was actually the tides that were moving it, because it was taller. The tides, when the waves hit it, it pushed it along the bay. But what you see here is this conflation of subject and object in the experiment. The grid is not some passive thing. It's actually part of what's being affected and being changed in relationship to the landscape. So I call this kind of work, or what I'm trying to do here, design field work. I'll just lay out a few principles here, where I consider it as a hybrid practice of field work and design intervention, in which each is informed by the other. They're inseparable. Very much about co-creation of understanding landscapes through immersive encounters, by making and doing, and then seeing what kind of things unfold through that as an experiment. Embodiment and aesthetics, putting the designer's body as in the foreground of sensing and sense making in relationship to technology and landscape media. This comes from two critiques of landscape architecture. One is the will to abstraction of landscapes. And secondly, that I think landscape architecture is largely a conceptual discipline that really sort of forgoes the designer's body. And we rarely, if ever, do the actual work of landscape manipulation. We're very good at bossing other people on how to do that, whether it be machines or people. Iterative learning, testing the relational capacity to act and to be acted on, or what's known as effect, within the unique conditions of a specific place and time. And lastly, trying to create sort of a sustained engagement with the landscape, rather than just coming in and going out. But what kind of relationships do we have or foster with landscapes? So I'll move into a second experiment, and this one I call assembly. And this was a little different in terms of, I was a little motivated by the San Francisco Bay subtitle habitat goals, where they're looking to try to restore different types of habitat that have been changed by how the bay has been changed. And they say sort of protecting habitat and applying restoration methods experimentally, because it's not really known what's going to work or what's not. And acknowledging that that's a very vastly different condition than what was there before. So based on the grid experiment and seeing what colonized those tires, I had an idea of trying to see, well, could I reconfigure some of these tires? There's more than enough tires for me to work with. Could I create microhabitat for different things, such as crustaceans, fish, and things out on some of these undifferentiated mudflats? So I started making things like this and trying to form them into different configurations that would offer some sort of complexity. And let's see if this works. I'm going to try to show you a video of how this was in the landscape. Hold on, it's thinking. Oh, it's really trying. It worked this morning. But what I'm trying to show you is what you see in that bottom corner is it's a video of this thing being subjected to the tides as it's out there in the water. There you go. So this is my first experiment, and you can see as the tides come in, working it over. You can see some of the tires already coming loose. This is what it looked like 4 days later. So it clearly didn't work. It's falling apart. As Sean was mentioning, a design failure. And I tried to learn from that. I tried it again. This time with 42 tires. I tried to dig them in deeper, tried to really wedge them against each other. Came back 15 days later, another failure. I tried it again, reconfiguring it, this time laying the tires flat, but stacking them and filling them with mud. 4 days later, it was falling apart. Tried it one more time. Assembly 4 with 63 tires. Again, each time I'm trying to dig these in deeper into the mud, trying to hold them. You can see now I have these ones on the outside, trying to wedge it all in. Completely useless. 7 days later, it's all falling apart. So I'm sort of playing with the tires at this point, and this is the last one where I just stacked them all up and was like, okay, let's see how much they do disperse. And so clearly, if they're, the tides are moving these if they're not pinned down, and 10 days later they were everywhere. So I was getting a sense of why the tires were all over the place. So all of these were sort of these fast twitch ruins. None of them worked, but I learned from it. And so I tried something new after that. And this is called Tideline. What you're seeing here is I'm trying to start to array them in a line. And the lines you see across the landscape, that's me. You can see all the tires out there. What I was trying to do is dig out all those tires out of the mud, which is kind of hard, and then drag them, or roll them across the mud flat into place into this line. So this is the beginning of that. Again, you see the lines there. And just coming back after multiple times and making this thing longer and longer into something like this. So it's called Tideline in that it's actually placed horizontally to the tide, and you can see the tide coming in on it here, where it works it the whole way across. And the sinuous form, I kind of like that aesthetically, but it was also to try to test all different types of aspects and directions with the wave energy to see how it would respond, because you get this kind of diversity of conditions that happen along it. And because my previous things really failed in terms of trying to get some verticality out on that mud flat for something to take purchase on, what I'm doing here instead is I'm getting verticality across the length of the line. So between one end to the other, there's about 2 foot change in elevation. So I'm trying to do that. Why I laid them flat, as I noticed in that first grid, when they're laid flat, they don't move as much. Very simple learning, but here's some more detailed images of this up close. And you can see there where on the left side, it's accumulating sediment. That's on the uphill side. And on the other side, it's not, and all the things that are growing on it. This was also during the COVID lockdown, and there was one point where I wasn't able to come out here for about 6 or 7 months. And the tires, I had purposely placed them bare side up where there's nothing on them. And this is the kind of growth that was happening on them, which was quite surprising to me. So this kind of co-creation, snails, the mussels, the various types of kelp and things that were taking this over. And part of my motivation in putting this out here was if I cleaned up all the tires and actually called attention to them, which this form, looked constructed, obviously, what would happen to it? Would other people add on to it? Would people decide that maybe they should clean the tires up? How are they going to react to it? It was kind of the opposite of the grid where I was trying to disappear. Here I was calling attention to it. And this shows all my track lines. I carried a GPS unit as I worked. And this is a close-up version of that. So this is just showing an example of about 6 or 7 excursions out there and tracking my movement as I'm going and fetching these tires and then trying to fit them into place. And, if we remove the aerial. I think this gets at this notion of co-creating where the lines are showing me where I'm going out to affordances in the landscape where the tires are, and then trying to bring that into some sort of willful design intent of the form I'm trying to put in there. So there's this, I guess, co-creative lines of flight that you can see in the landscape. One last experiment here. This one's called Tide Pool, and a very different condition, again, still in the same area, but here you're looking at a former ruin of an explosives factory that was on the coast here, and you're seeing the mud flat at the bottom of it, and up towards the top is where the wetland is. So it's still kind of in that tidal zone, but this one is covered in bricks and debris and all the stuff, and pretty much an undifferentiated plain. A lot of mystery here for me when I went out there. I don't know exactly what state this was left in and how the waves and the tides have sculpted it, but it just kind of has this single layer of brick and debris kind of laid across it as a coastline. And again, thinking about habitat and how habitat might be created out here, I started to play around with it, and I was kind of just got, I don't know why, but was drawn to these steel cylinders that were on the ground, and I don't know what these were in the past. But I started to, this is a drone series. That circle you see, I started to build on it and play with it. And this is the start of something. And then seeing, in one day, how much can I, sort of do my weird masonry out here of, dry stacking this up into this form. And my goal here again was to try to differentiate this plane and to create microhabitat. This creates a huge amount of pore space for all these crustaceans and things. And I was also trying to create a place for mud to fall out in the middle of this, because it creates a pool that'll then slow the water, and that'll happen within. So all experimental. I didn't really know what was going to happen. And this is showing how, on multiple excursions, building it up over time. You can see on the left side, that's the bay side, when it would, I'd come back and the bay would have worked it over, or like this after a storm, would push it back in, and then I'd go out there and I'd fix it and put it back as I had wanted it. And you can see the mud accumulating in the middle. So, then I'd come out, put it back, and have this neat arrangement, and then, the tides would work it over again. So I'm sort of having a dialogue of learning how the tide, sort of distantly related to the idea of resilient shorelines, like how do the waves actually move this particular grain of material? Larger view of it on that coastline as it builds up. These images are deceptive. It's quite large. It's a lot of brick. This is about 30 some hours of trying to move this material. And it's really interesting. If you stand by it, you can actually hear all of these creatures living in it. Whenever you just lift up one of these bricks, there's all these crabs and little sand fleas and stuff underneath there. But this thing sort of hums. It's got so much stuff living in it, and I'd love for someone to help me figure out how to monitor or figure out the pore space and what's actually happening within it. And again, I'm working when the tide's out. When the tide comes in, it comes in, and let's see, I have one more. I'm trying to show you one more video if it works. Oh, lucky. So there it is when the tide comes in. The land isn't moving. That's my drone trying to stay steady in a very windy environment. You can see there. So come in and work it over. And so I'm using the drone, to make these really fine-tuned digital elevation models, so I can see, after different storms and looking at the tides and things, how this might be affected. And this is just an early form. This is very much in process. It's not done. I'm just starting to work with it. So to see how the waves affect it. And, there's this kind of relationship of how I'm doing this kind of dry stacking of the bricks, and then the waves come in and do what they do and sort of create their own, chaotic dry stack of the material. That's down in the mud in the middle. So there it is on the larger shore there. And so, this is a start, and, trying to work again immersively with these forces and actually being out there and monitoring and sort of creating, I think a sort of intimacy with landscape that is really pushing against this kind of abstraction of, generalizing across landscapes, that, each landscape has its own attributes, its own diversity, things about it, and trying to explore it in this way through direct manipulation and experimentation. Thank you.
Great. Thanks, Brett. So we will move into the discussion section of the session here. So feel free, if you haven't already, to use the Q&A function to ask questions. And it looks like we've had answers from our panelists already there. But I think I'll just start out with Keith in asking some questions of the panelists. One really general one, I think, for all the speakers was sort of, why field work? Why do this now? And I think this is kind of why you guys are in the same session together. But, field studies, field work has been a thread in landscape architecture, stronger at other times, weaker at certain times. And Iryna mentioned the kind of top-down and bottom-up processes. Brett, I think you mentioned how we're a conceptual discipline and we love bossing people around. That is true. I've definitely had to explain that we don't build stuff, we just hand it to somebody, which is difficult for people to understand. But I think, everybody who spoke talked about tools for simulation or modeling and field, or I guess most presentations dealt with both, the sort of both and. It wasn't like, exclusive. So Sean had, working with a physical model, Monica's working with, simulations, Iryna is working with remote sensing, and Brett, you're constructing it yourself. So I'm just curious if you guys can answer the kind of general prompt of the session about, why think about the strength of fieldwork now? Oh, I'll have to pick on somebody to go first. Let's see. Well, let's pick on Sean first, since you're unmuted.
Yeah. Like I was going to volunteer anyway, I promise, Anya. I think that I think one of the reasons is that, I don't know, I think it's like, I don't think maybe there are a couple of reasons. Like first is that it's proving, it's one of these things where like the more and more we think we know about like the world we work in, the more and more we realize that things are indeterminate and difficult to kind of pin down, particularly like when we're through kind of standardized methods of abstraction that we tend to use as designers. And so and whether or not we're going and doing kind of field verification of things to justify or like kind of demonstrate the kind of accuracy of this or that like model or hypothesis, or it's just a matter of like, as landscape architects, one of the things that most of us, I don't want to say that this is like a required component of the landscape practice, but experience actually does matter. And experience is quite, is either highly augmented or quite separated through certain forms of work. And so, I think that there's this idea that like experiment and experience actually have the same root of a word, like they're actually similar versions of the same thing. And so how you get this idea that it's hard to understand experiments without experience. And as designers who are thinking about the experience of places, doing it entirely from kind of detached and abstract, we'll say distanced ways, is actually doing a bit of a disservice to our discipline, which might not be the same for other disciplines that like aren't so engaged with this idea of like experience. So that might be my just general reaction, since you picked me first.
Brett, you're unmuted. You're next.
Well, I don't know. I feel like I kind of said this, that one of my biggest gripes with landscape architecture is its constant abstracting of landscapes. And I like to, in some ways, I guess I feel like I'm an advocate for landscapes and their diversity and their intersectionality. And they're like, I think we suppress its place specific, non-reductive essence of what it is. And I have a visitor. So for me, I think the only way that we can counter that, and the way that we just sort of instrumentalize and generalize, is to actually engage with it, because I feel like that's when there's so much richness there and so much that gets overlooked and so much. That's for me. I think that so much of it, so many people have so little direct experience with landscape medium these days. We're all doing this kind of stuff all the time. So I think I don't know, I could go on and on. I mean, I think it's a whole colonial legacy if we really want to go there. Like, this is not how people used to live in landscapes. It's always been about projecting and abstracting them in order to control them. So I think getting out into the landscape and working with it is very humble, or hopefully create some humility about what landscape actually is. I don't know. You provoked me now. I just said a whole lot, but yeah. I said too much.
I guess I'll go next. I actually made a note from the first day about different, one of the speakers had talked about different lived experiences, and I thought, that's so cool, and kind of how we're designing things now. So as engineers, we typically like to cookbook things, right? But in coastal engineering, in a dynamic environment, you can't function that way. So when I first started my career down in Erdic, there were three groups: prototype analysis, modeling, numerical modeling, and then physical modeling. And I was in the prototype analysis group. So I learned by doing. And I think that was really key in terms of how I moved forward with these projects. And I think that's key for the coastal engineering community in general, is that, when you put something out there, that I loved Brett's presentation, because one of my first work units was detached breakwaters for shoreline stabilization. And I had people trying to sell me tire things all the time. But now I know, after a career of experiences, how that would work. And maybe you can't jam it into a cookbook or some guidelines or something, but you can adaptively manage it. That's why that's such a key phrase for me these days. But I love trying things. I love doing them. I love managing the expectations of what the outcomes might be. And really that one slide I showed of Gull Island, where we let Mother Nature take control and move the material, was really key too. I think really using the force of nature to do what we want it to do, but it's not always predictable. So we have to manage that expectation.
I can chime in as well. I think from a remote sensing perspective, there's been so many excellent advances in the algorithms and tools and data, and there's so much push on the kind of the cutting edge frontier of that to be better at detecting, be better at the frequency, the resolution, and other things. But one of the things that I've realized through all these different experiences and case studies is that still does not give you an answer of what's behind. You can be really good at describing your pattern. You can be very meticulous with modern tools. You can be even multi-scale and provide very different perspectives on it, but it still does not give you the answer what is driving it. And what's more is that the same type of signal of change could come from very different drivers in different contexts, or even their interactions. And I think that is also a very humbling realization that really kind of forces us to go to the field, involve models. Even field work sometimes may not fully give you an answer, but it does provide that perspective. It does show you where the uncertainty might be coming from. What is it that we really don't know when we interpret the images? Or why are we seeing certain roadblocks like mapping inaccuracy or other things, no matter how much better our tools are becoming? And I think that perspective is central even for people who primarily work with digital tools, just to go out and see, experience, ask questions, see what you don't know, and then find the right people to collaborate with, even if fieldwork is not necessarily your major part of activities in this regard. So I think it's highly available, and I fully agree with everything that the other speakers have said as well.
Super interesting. Thanks. I just wanted to sort of provide an opportunity for folks to reflect on, the basic question of why be in the field, because I think it is, in some ways, for the discipline, kind of an obvious one, like landscape. You should be in the landscape, but it's becoming less obvious now. Keith, did you want to pose a question to the speakers?
Sure. I'll try to follow up. I was frantically scrolling notes while everyone was giving his really engaging presentations. And first, I want to say thank you all for some really interesting, very clear and exciting set of projects that you presented. And one of the things that I found particularly inspiring in all of them is that there's a kind of recognition of a necessity for the expanded project of design when we're thinking about conservation, preservation, and restoration of our coastal environments. Like all of them in some way take the inherent variability and uncertainty in those landscapes as a virtue, and really start to think about how we might radically kind of remake the institutional practices and protocols of planning, design, and engineering in dynamic environments. So I found that to be especially kind of, I think, inspiring and liberating in some way. But one of the conditions that came up that I was thinking about in a lot of the projects, and kind of relatedly, is the kind of a two-part question here. It's kind of like scale and scalability of a lot of these projects. A lot of the examples, for instance, are very kind of acupunctural, very tactical, very local. And as such, a lot of the kind of practices and mandates from those projects arise out of the particularities of those, let's say, those kind of in situ engagements. But as Iryna was talking about, for instance, that the drivers for certain landscapes and the subsequent patterns from it really change at various levels, and don't necessarily, even though they're interrelated, don't necessarily kind of translate easily from small scale to mid scale to big scale. So I want to get your perspective of how you think about these projects scaling up in some way. So this kind of idea of scalability, of how these very kind of contextual, sensitive strategies like, sediment placement or these kind of site-based experiments kind of replicate more generally to regional or national systems. And I wonder at times, do you find that there's a kind of an inherent contradiction or kind of obstruction in that next leap of application at bigger scales? That's to the field. No one in particular. So Brett, I mean, for instance, I'm not going to single you out, but yes, you walking a landscape. What about the landscapes for, let's say, Iryna was talking about, that are inaccessible to the body, or kind of are at larger dimensions from what the sensing, a body can actually perceive, and the ranges and the limits of that. How do we start to kind of translate and transgress to landscapes of kind of other dimensions and other scales? And I think we could talk a little bit about the affordances that remote sensing capabilities enable for that.
I think, are you referring to me with this question?
Well, it's everyone, but kind of Brett and Iryna in that kind of concert, and then maybe Sean and Monica when we're talking about these kind of coastal protection features, and thinking about the dynamics that drive a lot of those interventions might be different at other parts along the coast, even in New Jersey or in the kind of Delaware side of the bay.
I can go first a little bit. I think with just thinking through this question, it's an excellent question, Keith. Thank you for asking that. It strikes me, and it also strikes me from a remote sensing perspective, how similar are wetlands and cities in many ways, even though they're completely different ecosystem types. They're all heterogeneous, they're all dynamic, They're all complex in the reasons that we don't even the advances in environmental science in that regard, we don't fully understand. But one of the issues in scalability is that we have a lot of power in both wetland and urban contexts. We have a lot of power of design and engineering at a very local scale. We can manage hydrological effects, for example, to allow them to accrete the soil, like I mentioned. Or we can also be very innovative in terms of materials, vegetation designs, and other things for mitigating urban heat in a local park or even a neighborhood. But the real effects of these towards broader population, the real effect of these towards equity, towards avoiding issues like gentrification around nice school green spaces in cities would only be visible at these broader scales. And I think one of the things is that comes up is that the need for distributed solutions, like these prototyping of design, deviating a little bit from the uniqueness of the site, not abandoning it, but plugging it in later when you start applying these solutions. I think these modeling tools really illustrate that you might want all these nice embellishments and beautiful artistic visions when you're designing it, but they would be really hard to replicate and they would be even really hard to model. But you can always add them later and you can tune them to the nuances of your site when you start applying that prototype across a broader level. And that's where I think a lot of understanding is still missing, both in the context of restoration and in the context of urban heat mitigation. So much thinking has been bottom up and so much pattern detection has been top down that we're missing that middle scale. How do the neighborhoods and synergies at neighborhoods really then decide whether you have enough or not? If you have only one wonderfully designed cooling park in a whole large hot city, it's not going to do much for that city. But if it's part of a network of smaller and larger sites that are connected and they amplify each other's effects synergistically, then it might actually benefit different parts of the population in different neighborhoods in a more or less equitable way. So I'm trying to think in that regard, but I don't feel like we are kind of quite there, even with the spatial sciences behind this. It's a very important direction.
Yep. Yeah, good hard question, Keith. I think about this a lot too. I quoted Anna Tsing, the anthropologist there, and she has been very critical of this idea of scalability as sort of an instrument of control and things. And I've kind of already hinted at this, that I think there is. It's hard, right? Because if I sit there and play with those bricks on that shoreline, in some ways, I'm going to be able to extract some principles, right? That's unavoidable, but I would also say, it's also specific to that bay, that climate, that wind regime, that so many things that are of that landscape's own thing. So I can just throw it around, but I don't have it resolved either. But I tend to push back on the assumption of scalability as a yet another form of abstraction, and the will to try to make things convenient, and rather than to do the work of being very site specific and being very place based in practice. So I think we always try to scale up as like, oh, I need a formula, boom, and then I feel that, but at the same time, it's not like there's not principles that come out of things, or that someone might not see some tire things here and be like, well, I have all these tires in my thing, so I'm, there's clearly that. So I don't have a clean thing, but those are sort of some of the tensions I see there. I think it's a great question.
Yeah. I mean, I agree with Brett, I think, in terms of, but clearly there's some, with the work that we do, there's some, so for example, like in Illinois, we have communities farther south in Illinois that have kind of like literally been like, oh, we want a rubble ridge project. And you're like, well, I mean, I don't know if you look at the work within the initiative that we've been working on, every project looks and works incredibly different. And that's because it's drawing a lot of inspiration from like the processes that are taking place in those individual places. Not just like physical landscape processes, but like kind of social and economic concerns associated with the places as well. Sometimes you have money to do something, and sometimes you actually have to have the waves just like push the stupid rock down instead of like actually placing it in the water. And so I do think that there's also this kind of balance between like, so I would say that like what we advocate for is saying like, actually there's a method of working that is like, that you can transfer from place to place. But that method is actually like about really deeply figuring out what makes a place work in a particular way and figuring out how to like work or maybe like dance with it in a certain way, in a way that's not, that isn't like a cookbook, where you kind of do the same thing over and over and over again. But if you can at least try to figure out how you develop a kind of working methodology that can transfer. There are efficiencies that can be built into this in ways that seem attractive to like actual normal work, or people that are actually trying to build landscapes and that sort of thing. But yeah, it's also been strange for the New York project because we have these other communities down the just to the west in the same county who are also interested in kind of doing the dredge wedge thing. And you're like, well, we don't know if it's going to work there. You can't just like do the same thing in the same place and assume the thing is going to work, particularly when the things were designed to be very site specific. It's different with an offshore breakwater. You can kind of throw it wherever and it's likely going to stop waves when they hit it. But the problem is that that's one of these things that's like big and dumb and built in with all these contingencies that like make sure it just kind of works everywhere. And in most cases, it ends up being like highly inefficient and also just like not very sensitive to a place. And so in many cases, it doesn't care. I've like kind of gone on this rant before where it's like, I've designed the same horizontal breakwater for like New Jersey and Texas and Alaska, for example. And so you're like, at what point in time, like, do we actually say that clearly those landscapes are quite different socially, culturally, performatively, and the fact that we can just kind of deploy the same solution across all of them, like, should like throw up some red flags, at least to me. But so my argument is like, I think similar is that we should be trying to find ways where we can maybe efficiently incorporate like a really important like kind of components of actual places so that we can operate in a more sensitive way. Whew, sorry.
Sean, can I ask a question? You gave us that four ways: landscapes by experiment, of experiment, experiment of landscape, landscape as experiment.
Yeah.
Does scalability vary across those?
Oh yeah, I think that some probably are quite like kind of particular in terms of scales and others are not. I haven't thought about it too much. Like I haven't been like you. I try to avoid this whole kind of scale question altogether in many cases because I think it's can be a problem because we're always asked to like, how do we scale this up? It's a pilot project, so it's supposed to like go everywhere. And you're like, actually the pilot is the idea of how we're working versus like the thing we're actually making. So yeah, I'll have to think a bit about that. But I would generally say that like there's definitely kind of like scaled components within those categories. My assumption, Brett, was that you had already thrown those categories down the stairs and shuffled them. So I was hoping you weren't still thinking about them.
Oh no, we'll have to chat more about those. I'm still thinking.
Okay.
I have a question. Oh, sorry.
Go ahead, Karen.
Oh, I have a question about time. Scale's a big term. Time's another one. In terms of so Brett, when you started your description about the grid survey, which seemed completely open-ended and there was really no expectation of what would happen, in contrast to the kind of ornamental tire arrangements, which you said were failures. And I thought, given how you started your presentation, that failure was not even a possibility in your framing. That it's just an ongoing process of remaking, and then it happens to create habitat, and then, but not with a predetermined goal. And then with like Monica and Sean, is success on a spectrum? I mean, you also talked about if something's failing, and it sort of is working in opposition of talking about adaptation. And so it's just the question of like, how are you determining under what time frame that something is a success or a failure?
That is an excellent question, Karen.
Yeah, I guess I'll jump in here because we've been having that discussion. For sites like Avalon, some of the people doing that monitoring are looking at a 25-year time scale for monitoring to determine whether it's a success or a failure. And we're kind of, pushing back on how to define that, because of the first bullet I had on the end slide is the status quo is not an option, right? Climate change impacts and all that, we have to do something. So we're trying to change the language on that. Also, though, in the Corps of Engineers, in the mission to clear the navigation channel, we're supposed to clear it and walk away, not monitor. But we're trying to change that, because if you can work with the agencies and have a repetitive place to go for the material each time we're going, then maybe that project becomes something you dredge a little bit every year over a long period of time. So that kind of goes to scale too, right? So should it be one big one and done placement operation, or can you really stretch things so that you are doing it over a time scale that makes sense? And then again, managing expectations at the same time. So I think it depends. And I'm going to touch back on scale too, because we're being encouraged to go big, right? To go bigger scale. Some of these pilots were 6,000, 7,000 cubic yards. A project like Salem River is 150,000 cubic yards. I'm truly excited about that, but it really does depend. The other panelists kind of said the same thing on the uniqueness of the site. So if you're restoring wetlands in coastal Louisiana, time and scale, they're desperate. They're desperate for it. So do no harm means something different to them versus something different to a small marsh up in New Jersey. So I think scale there is important in that it depends. It depends what equipment you're using. It depends where you're getting the sediment. Depends on your funding source. And so not everything's always perfect. The other thing I just wanted to mention too is I'm starting to look at that scale factor and I guess the time factor too as high risk, low risk, high yield, low yield, right? So kind of balancing those factors with each site and then throwing in, I think, the time and the scale question too. And the visualization, which is why Keith and Sean are going to help on, and Karen are going to help on some of these. So how do we visualize all that? I will say another thing on the scale factor is we're down in the mud. We are learning how to build mud flats and how every grain of sediment is going to collapse. And we're studying that. I do think those lessons learned are going to be scalable. And I think they're going to be scalable to communities, whether they have 1,000 cubic yards or whether we have 100,000 cubic yards. We're going to be learning on that technical side.
I'd like to follow on a little bit of what Monica was talking about, and this is just a basic, I think, theme across all presentations, right? Is it's the title of the session, monitoring change, right? And I think that the part that I'd like to get into, if I'm right about who's participating in this session, is it's a lot of landscape architects in practice, as well as in academia, and monitoring is always something that is not part of our service portfolio. We can't get people to pay for it. My own firm did an experiment where we tried. We had a whole service contract and we said, we can do post-occupancy monitoring. Don't you want to know about how great this site is doing or bad? Or maybe they don't want to know. That's fine. We can just know. Nobody wanted it. It's like we would actually prefer to build it and walk away. That's just the model. So I'm just curious from, this is kind of a general question. Sean, you were talking about it as critical with the experimental landscapes. I think, Monica, you were talking about adaptive management, some additional manpower from Boston College and UPenn and monitoring. But just how do you do it? How do you build it into a system that's not optional? And how do you learn from it?
I'll speak a little bit about an effort. It's a little bit more nuanced in wetlands, but we actually have a regional effort right now, which illustrates a great example of that. It's it's an effort called Wetland Regional Monitoring Program, and it's coordinated by San Francisco Estuary Partnership, which involves multiple agencies. There's California Water Board, there is federal agencies that oversee certain estuarine research sites. There are some other groups, academicians like myself, who provide some expertise as well. They have a steering committee. It's a very coordinated effort, and they obtained some initial funding from, I believe, Ecological Society of America or something like that, to develop this idea of a general blueprint. Like, what are the biggest management questions that are pursued by various monitoring efforts, and what are the metrics, indicators that would be required to assess the performance with respect to these management questions? Which of them can derive from remote sensing, which require field work, which should be the reference sites that would provide kind of some prototypes and baselines, which would be the sites that could be monitored specifically as the ones that are changing really fast. And it's not meant to kind of become some overarching, the only way of doing monitoring, but it's meant to provide guidance, enable comparative analysis, and then provide a framework. And then individual sites, individual groups that are doing their own restoration efforts can plug into that. They can participate in parts of it, but that provides basically a bit of a centralized way of kind of how that should look like to reach meaningful conclusions about how the sites are adapting, responding to ongoing change, and so on. And I'm participating in that as one of the science experts, and it's been a really great learning experience about the realities of it, but also how to streamline this universal thinking.
Yeah, I mean, I guess I would say that, I mean, I'm interested. I made a whole bunch of like silly generalizations about practice, Anya, that you confirmed with like this idea that, like regular projects don't involve monitoring. It's just not something that people want to pay for or interested in. And I think a lot of it is like the kinds of projects I would imagine, say, for example, like, or the way that you decide to work. Like that, I think the goal is to like only work on projects. And I can say this because, I am in the academy and my office doesn't have to make any money. So the idea that like I only want to work on a project where actually monitoring is a fundamental component of it. Like if you can't unplug it without unplugging the project. So there's actually something about, and this kind of goes to this issue of time too, is that there is, I don't know, like to some degree, like there is no time scale. Like it's like you work on it forever. Like everything is forever, basically, until you quit doing it. And so as we work on our shorelines, we're not going to have a solution that's going to work forever. And so you basically you can like set these baselines that say like, okay, so this has to work hopefully for 25 or 50 years on a certain horizon. Or you can just admit that like, even when we do that, we end up redoing that 25-year plan in 5 years and pushing it another 25 years out. So how about thinking about the fact that like that instead we just kind of admit that what we have to do is kind of develop these long-term relationships with our landscapes that involve constantly interacting with them or studying them or monitoring them and responding to them kind of in perpetuity, and just admit it, that that's what's going to happen, instead of trying to like solve the problem and then step away and move forward, which you almost have to admit that that's what's going to happen in coastal landscapes. It's a little different, say, if you were designing an urban plaza or something where the people are like, I mean, yeah, it's going to be fine. It's like concrete and benches and stuff. Like you don't need to monitor that. It'll be fine. But when you're talking about building something that's actually supposed to protect the shoreline, I mean, if it doesn't work, you're in trouble, basically. And it's a system that's changing constantly. So monitoring has to be part of it. Most of these coastal projects have to include monitoring or they don't get passed or approved. So it's maybe a little different, but I'm trying to answer both questions at once, poorly.
Well, Sean, and something that you just said, I think resolves neatly with one of Brett's sort of earlier points about the specificity of any of these sites, is that when we try to abstract away and come up with policy that's meant to match any kind of type of problem, that could lead us into trouble, especially as we get into situations that are sort of full of uncertainty. But if monitoring is the response, this kind of attention and care and working through conditions as they emerge, and that becomes the design strategy, then I think there's an interesting resolution there between these two ways of working.
Yeah, I agree. I think that, like landscapes need tending, and there's this kind of myth, very contemporary or modern myth, that landscapes don't need tending.
Anya, I'm so sorry to interrupt, Brett.
Okay. But I also think that gets out to, I think we need to get more people involved, sort of like the community science and creative ways. Like, how do we get people interested that this stuff matters, that it's interesting? Like, people might not be interested in my tires, I don't know, but these larger projects or whatever, right? Like, there's, look, your kid's future depends on if the shoreline works. So maybe you should come out and see if it's working or not. I think to me, it goes back to, this embodied, cared for landscape, place-based practices. And I don't mean that in a fluffy way, but really, like, how does it matter to people who, live in these places, especially if you're around the bay? I mean, the whole thing is vulnerable. So I think how we get more creative about who is monitoring and the public role in this, and which gets back to our larger advocacy and getting, I think as designers, our obligation to the public, I think is important here.
I have a kind of following up on this, because I want to hear Monica's response to it. Because one of the things that struck me in some way was Sean talking about the kind of long-term commitment to certain landscapes. When you think about the way that the Corps is organized into districts, right? And then there's a kind of accrued knowledge by the members in those districts to really become embedded in those places. That seems like a real kind of benefit and boon in the structure. But I'm sure there's also some impediments to that. One, I'd like to hear your thoughts on it, and two, as a kind of maybe unrelatedly, but I wanted to make sure because this question is kind of directed to your presentation, Monica. Roberto Rivera talked a little bit how struck he was about the language and terminology have shifted, and how coastal landscapes and landscapes in general are understood and approached. For instance, sediment as currency, for example, and how how intentional has the crafting of language and terminology been in changing business as usual when it comes to intervening in these landscapes at this scale? So these are both very particular to, let's say, the practices and the institutional protocols of the Corps. So I wanted to just relate those two things.
So that was for me, I think. Yeah, so words absolutely matter, and changing that language, I mean, it's like a knife in the chest now to hear somebody call it dredge spoils, when it's, we've completely changed the way we talk about things. So I think that has been instrumental, and that's where that word persistent came in. It didn't happen overnight. It's been a 20-year mantra coming out of the Regional Sediment Management Program that we need the sediment. Part of the reason we have so much erosion is because we're taking it out of the system. So we're creating our own problem. So I think changing the way we talk about things, that's something I've been paying a lot of attention to in my language, not just about dredge sediment, but about everything. Coastal system resilience right now is a whole big buzz phrase that the upper senior leaders understand too, right? So relate it back to something that they understand, system resilience. Yeah, so I think that was the first question. What am I missing? The second question on monitoring, right?
Yeah, because setting up in districts, and that you basically have certain groups or organization. Part of that organization is set within a particular area, right, for a really long term. And Sean was kind of referring to the investment long term with landscapes and the need that comes with that to monitor them.
Yeah, and so I've been definitely an advocate for monitoring for my entire career, especially with beach fills, right? So people would want to just build them, but we renourish them periodically every 3 years. So how can you just get a once-a-year survey? You need to understand what's going on within that natural system to be able to design the next one. And if we don't have monitoring data, how can you adequately design that? So I'm definitely an advocate for monitoring. Where I'm struggling a little bit, and this is one reason we created the Innovation Lab. In my role, I can do so much monitoring, but it really should be related to my mission. And Sean mentioned a lot of times you can't get approval to do some of these projects unless, there's some agencies out there saying, I want 10 years of benthics or invertebrates monitored, when you build a mud flat. That's $250,000 a year, for something that's not in my mission necessarily. So we created the Innovation Lab as kind of a forum where we could work together and leverage some of that monitoring, bring the questions to the table, and then prioritize. If there is only a limited pot of dollars, how can we use that most effectively? Can we get the answer to what you want to know and answer to what I want to know by going out in one field event that collects a lot of data at once? So I think the money issue for monitoring is, I'm willing to pay for what I want, but then when I get told, no, you got to pay this huge, price tag to get something that somebody else wants, then I get a little uneasy and I don't support monitoring as much as I just said I do. So it's a dilemma.
Panelists, questions for each other? A little crosstalk, a little cross-examination. Something that's you find curious or you got a question about, and the others work.
Ryan, I have one for you. You mentioned the way that indigenous land use used to burn the tules and things like that. Do you have ways that you might be able to try or working towards piloting that or anything with that?
That's a really interesting idea. I think I come to these projects, the wetland projects, more from the remote sensing side, but the colleagues that I collaborate with, we have discussions around it. And the Department of Water Resources that is kind of engineering and overseeing these particular sites, they have been thinking about burning and some of these other strategies. And it's interesting how the research that also involves traditional knowledge comes up right away at this time from other groups that show, for example, the evidence of the charcoal in the soil sediment and some other kind of historical analysis of the region. I would love to learn more about this because another kind of going back to this Anthromes map and other things, that a lot of things that we perceive as pristine, or we call them natural processes, are the processes that evolved from a long history of human interactions with nature, both in the wetland context and in other benefiting from cooling aspects of vegetation and other landscape features. I think there's a lot to be learned. And I responded to a comment that was in the chat about this and to what extent this is being considered. There's been a recent paper by Joey Zedler and a colleague who published basically a comparison of the Western thinking and the traditional Native American thinking in the context of restoration, specifically in the Delta. And they also proposed specific ideas on how to move forward towards this ecocultural restoration, honoring the legacy that we have, but also incorporating that knowledge. So definitely a lot to learn. It's a long answer, but I think I'm really humbled by learning more about this. And I'm not from the US, I come from an Eastern Europe where similarly, there are a lot of traditional knowledge that is being now kind of buried with urbanization, with a tendency to mimic Western lifestyles and modes of living. And I really would like to have a better understanding of that and think how that could inform restoration and management and adaptive planning of ecosystems as well.
Thanks. Yeah, I'd like to follow up with you at some point on that. We're doing another project in the Delta and it's come up. And the way that it also, from what I understand, it can really help with subsidence reversal because it slows down when you don't burn that stuff. And then when you burn it off, it actually creates all this regenerative growth and can actually speed that up. So yeah, I'd like to catch up with you later if I can.
Let's go. Absolutely.
That's maybe a nice place to end this really kind of fruitful and energetic conversation that we had, and the other two sessions over the course of this week. And I want to thank everyone for taking time out of their busy schedules to spend it with us. And with that, we'd like to hand it over to the Wilkes director, Billy Fleming of the McCarg Lab, to kind of talk about the kind of big picture and where we're going next.
Well, thanks for that, Keith. And before I do that, I just want to say like how lucky we are in the center and the department and the school to have Keith, Karen, Sean, and Robert, involved in starting up MLab and putting all of this together. Obviously grateful to all of you who've taken time out as panelists and attendees for the event. But yeah, it's such a pleasure to have the four of you here and to be able to launch the MLab properly like this. So I'm going to be pretty quick, but I think my job is to kind of put this into a broader context for us. And can you just confirm that you're seeing slides and not presenter notes? You're good? I see thumbs up from Keith.
Well, we see your slide. It doesn't look like you've gone full screen yet.
So this is not full screen?
Not to me.
No.
Okay, one sec.
Yeah.
We tested everybody but Billy.
I know, this is what I get.
Yes.
Okay, cool. Thankfully, I have no notes for you to have seen. So great. So this event is the first in some ways of a series we're putting on, but in many ways actually the continuation of something we've called the Public Forum series in the McCarg Center for several years now. Possible through a gift, actually the second major gift to the center from Bonnie and Gary Sellers back in 2018. That's allowed us to do a number of different events pre-COVID that were in person. This one, the first one with Jeff Goodell, author of The Water Will Come, so a book talk that he, Ellen Nisis, and Brian Kahn, formerly of Earther and Gizmodo, now at Politico, had about his book and some of the challenges facing sort of designers, planners around issues of sea level rise, particularly in Miami, where Jeff's done a bunch of work. The second event in that series was this one with May Bouvet. May's the former, but then executive director of 350.org, alongside Helen Gim, our city council member here and future mayor probably, board of advisors member, Mark Gardner, also practicing architect, and then Barbara Brown Wilson at the University of Virginia, kind of asking questions about, at the beginning of the Trump era, where planning and design sort of discourse fits within some of those larger political machinations. Not long after that, through a different pot of money but a related event series, we're able to put together this event called a Blueprint for Adaptation, featured among many other people, our very own Karen McCluskey and Keith VanDerSys, who would go on to then author a chapter based on this talk in a book that came out of that event called A Blueprint for Coastal Adaptation. And then the last event sort of predating this in that series, and really kind of the last before we began what we're the kind of phase we're in now, was this one, Designing a Green New Deal, back in September of 2019. You can look at the full list of people there if you'd like to, but just on stage really quickly, you have Elizabeth Fiedler, my state rep in South Philly. Next to her, Karine Tayloe, who runs the policy office of We Act, one of the largest and oldest EJ organizations in New York. Next to her, David Roberts, formerly of Vox, climate reporter, journalist. Next to him, Rihanna Gunn-Wright, then of New Consensus, now of the Roosevelt Institute, who's really overseen much of the kind of intellectual development of the Green New Deal as a concept for the last few years. And then next to her, Leah Stokes, political scientist based at UC Santa Barbara. And beside them, Alison Lasker and Ellen Isis on our faculty. And the sort of intent of that event was to put designers and planners in conversation with some of the folks who'd led that conversation today to ask some similar questions. So I think would have been asked here today about where planning and design sort of practice fits within this larger, in this case, suite of technological change, but in that case, political and economic change. And of course, that brings us to Instruments of Change, which has been such a treat to be a bystander for the last few days. I think exactly the kind of event I hoped when we talked about this a couple of years ago or a year and a half ago, whatever it's been now, and is really, as Keith and Karen and Sean and Robert have mentioned, kind of envisioned for us as the first of many in a series like this. So the center in its kind of post-Design with Nature Now life is really focused on building out these different areas of kind of focused research. So the MLab, Environmental Modeling Lab, which you've heard lots of this week, biodiversity, which is sort of co-directed by Richard Weller and Karen McCluskey, climate policy, where Nicholas Pevsner and I sort of co-direct some work, and then in the public realm area where Sonia Dumpelman and Chris Moshnikowski do the same. And so in a sense, this week has been the kind of public launch event for the MLab. You all have seen lots of images like this from Keith and Karen and Sean and otherwise of all the different ways that they're trying to use downscaled spatial data for all kinds of purposes. But in many ways, you know, it's not only launching the MLab as kind of an official wing of the department in the center, but fitting within this longer lineage of the McCarty Center's sort of public forum series, where the goal is ultimately to put a bunch of really smart people who may or may not have direct sort of expertise in planning and design, though many of you do, many of you are kind of in adjacent fields, to put them into conversation with planners and designers within the department to again ask some of these critical questions about where physical and social and environmental science kind of intersect with planning and design practice and scholarship. And obviously now Instruments of Change is the first in this kind of second phase of events. And in many ways kind of marks the end of that older public forum series and the beginning of this process that we'll use to start launching each of the different working groups over the next few years. So coming actually in the next few years are this series of events here. In the academic year 22-23, our biodiversity group, I think in this case, sort of led by Richard Weller, Matthias Bau, and Rob Leventhal, are going to be putting on their launch event for biodiversity, mega eco projects. We'll have a date for you pretty soon, so look out for lots more annoying emails from me for that. Nick Pevsner and I will talk soon about a similar version of that event for 23 and 24. And then the year after, our public realm group will be able to do the same in the 24 and 25 year. After that, who knows? But it's been such a pleasure it's been such a treat to let this event unfold as successfully as it has been. And for those previous events in the series that I mentioned, the model has typically been for events like this to become vehicles for securing larger pots of money for the work, bigger pools of collaborators for the research, and bigger audiences to consume and engage with the work. And so far, at least, you know, we'll see how things go for our MLab folks. I have no doubt that they will follow that model very successfully. But that's the kind of path we're hoping to lay out for them, and would not be possible without all of you who kind of joined us this week as panelists and audience members, and certainly not without all the work that Karen and Keith and Sean and Robert did to put this together. So Can't say enough good things about the four of you, but I'm just so glad everything was wonderful this week. And yeah, thanks everyone for coming. I think that's it. I'll throw it back to Keith if there's like any closing remarks you want to say.
No, you if maybe Karen's, if Karen has something to say that took us in, but I think that's a nice way to end a really amazing and stimulating week.
Yeah, I would say the same
Unfortunate
thing.
we couldn't be together.
Yeah. Yeah. Thank you so much for that, Billy. That was a fantastic end. So really thank you to all for participating. And we look forward to sometime celebrating in person.